Uh, Welcome back. If you're here, either you clicked on a link that I sent you, or you just really have an interest in creating stable diffusion models. So this tutorial is hopefully going to be a lot cleaner version of the 50-minute tutorial I posted yesterday. I think I've worked out all the kinks, so we're just going to dive into it. Hopefully this video will be like 10, 15 minutes at the most. I actually laid out all the steps of everything we're going to do to get you all started with basic text to image generation locally on your computer without having to pay a cent to Midjourney or OpenAI or any of those companies that charge you for API calls. So I am Caleb Bradbury, PhD over here at Radford University. Bunch of people just want me to post some tutorials on how to use AI for everyday use. So here we are. If you see me not looking at the camera, it's mostly because I forget to look at the camera. And then over here, if you see me looking over here, that's because that's where I have OBS recording everything. I'm just trying to make sure that the video feed looks good. So let's dive into it. Here's the steps. We're going to download and install Python. This is, again, clean system. So I've actually already downloaded all this to speed up the video a little bit more, but I'm going to show you exactly where to get the correct versions and everything. So hopefully you won't encounter some of the issues that we saw on the longer video. So download and install Python. Download the Stable Diffusion 1.5 checkpoint file. That's the neural net model weights that we talked about a little bit earlier. And when we get to that point, we'll talk about that in a second. Download and extract automatic 1111. That's the GitHub thing that we're going to look at. Move the checkpoint from step 2 into the automatic folder. Start the web bat. Let the dependencies install. Go to the local URL. Make sure it works, and we'll generate an image of a beagle on a surfboard. So without further ado, you can get Python from python.org. The specific version of Python you want for this specific version of Stable Diffusion is 3.10.6 or 7. I think I'm using 6. Either of these will work. I tested both of them, so I could tell you which one to download. 3.10.6. So that's what we're going to run right here. Like I said, I've already downloaded everything. I'll post the link bottom of the YouTube video. This is where you can get it. Again, Windows 10, Windows 11, either this version or this version is what you want. So you can get it right here, downloads, Windows on python.org. Next thing we need then, since we've already downloaded that, we got to download the model checkpoint file. I mentioned talking about this earlier. This is the Stable Diffusion repository on Hugging Face. This is where you can get all kinds of cool machine learning AI models for different modalities, text to audio, text to video, text to image, image to image, image to video. You get the idea. All kinds of cool stuff you can find here. I showed it in the other video, but again, here's all the different modalities: computer vision, natural language processing, audio, tabular, and we can mix them all together, do some really cool stuff as well. So as I record more videos, we'll look at how these different models can work, what this instruct word means, all that fun stuff. Right now, though, since you want to do basic text to image generation, we are opting for Stable Diffusion version 1.5. It has a tremendous amount of support behind it. It's been around about a year and a half, 2 years, something like that. So we're going to rock this version. All right, so here's how you can sort of navigate around Hugging Face. It acts like a GitHub if you've ever used Git. I suspect if you're watching this video, you probably haven't, though. Big takeaways here then. It has 4 million downloads, give or take. There's some spaces where you can test this out on Hugging Face itself. Typically, you have to pay for that kind of functionality, and we just want to run this locally just to see what the big deal is. So we got the model card here. The model card explains what the model does. Different models do different things. So this is a latent text-to-image diffusion model capable of generating photorealistic images for any text input. In a later video, we will talk about fine-tuning this as well to create deepfakes. But right now, we're just going to download Stable Diffusion 1.5. So how do we do that? Here's how we can actually run it, but we're not actually going to even worry about that. We got 2 different files down here. We got the pruned EMA only checkpoint. Don't worry about the EMA only weight versus the full non-EMA weight. Let's just download the pruned for right now. And again, I already have that download. You can just click on it right here. Starts downloading. You can see I've already downloaded it. We're pulling a pretty decent speed right now, 100 megs a second. I'm going to cancel this because, again, I do have it already downloaded. So that's the second thing we need. So we got Python. We got the model. Now we need something to interact with the model so we don't have to just straight up use Python code to generate images. That's going to come in the form of the automatic 1111 interface. And let me just open up a new window here, new tab. I am bad about tabs, as you all can tell. So this is automatic 1111's GitHub page, and then the specific one we're going to use is the Stable Diffusion web UI. From prior videos talking about like downloading straight code versus version releases, I've tested version 1.8.0, so that's the version we're going to use. So if you hear a tutorial saying, hey, use this version, not that version, if it's on GitHub, you can go over to releases down here, click on releases, and you can scroll down just a little bit here. There's another way to navigate here. I just scroll though. So you can see 190 release candidate. Keep scrolling, 180. And then scroll past all the bug features, all the new added functionality, all that. Down here on assets, source code. This is lets you see exactly what this code does so that you can trust what you're using to generate with. Again, I already had that one downloaded, so that made a copy of it. But we got everything we need from the internet now. And hopefully, we're 6 minutes into this. Hopefully, we will have Stable Diffusion online in about 4 more minutes, give or take having to download PyTorch. So we got everything we need. Going to minimize the, we'll just go over to my downloads right here. So again, everything we need right here. Python, Stable Diffusion checkpoint file, and the automatic repo. I'm going to go ahead and extract this just because, and I mentioned this is a clean Windows machine. I don't even have WinRAR installed or anything like that. So literally just right click, extract here. It's going to extract it into my downloads folder. It'll make a subfolder. Once it's extracted, I'm actually just going to go ahead and drop the model weight file into the folder as well. So I opened up a new window. Don't worry about that. So that's the zip file right there. I know because it says compressed zip file versus the actual file folder here. That's what it extracted to. I am going to rename it. You don't have to, but I'm going to just rename it to like Web UI 1.8. That way I can keep track of it as we mess with different versions. So I'm going to go ahead and copy this down here. That's our checkpoint file we got from Hugging Face. That's the actual model. That's the thing we need to generate the images. This thing that we're going into is the user interface. This lets us actually use that model. But in order for it to work, we need the model and a way to interact with the model. So we're bonding these two things together. We specifically for automatic, we go into whatever the folder is, and there's a models folder. In the models folder, there's a Stable Diffusion folder. And in the Stable Diffusion folder, we paste the Stable Diffusion checkpoint. So I just hit Control-V on my keyboard to paste it. See my computer's chugging along, copying the file over. So again, nothing terribly exciting, but we are 2/3 of the way there. We're halfway there, we probably should say, but we won't quote Bon Jovi because, you know, the copyright and all that, I guess, in YouTube. I don't know. All right. Now we got to install Python. So this thing is not going to do anything without Python. So Python 3.10.6 is the one I downloaded. I've tested this several times. You can watch the other video to watch me use the wrong Python version and how to correct it if you encounter that issue. Uninstalled it. We're reinstalling it right now. Add Python 3.10 to the path. Again, I'll need that later. You don't have to if you don't want to, but I will need that later. So set up progress. It's going to install Python. This will give us access to the Python programming language interpreter. I don't remember which video I mentioned it in, or it might have been a classroom. Python is an interpreted programming language, not a compiled programming language. It acts as a instruction set that talks to another programming language called C. And once we get to the advanced stuff, we'll talk more about that. But Python's a very natural, very easy language to use. And it gets made fun of because it's kind of slow, but turns out all of the machine learning, artificial intelligence stuff actually uses Python. So that's why we're using Python for this. Setup was successful. I'm going to test it real quick. You don't have to do this step, but I'm just going to test it to make sure it works. So basic Windows command line prompt, and all I have to do is type the Python word, and you see you get Python 3.10.6. So I have Python working. A little bit of Python programming here. I declared x is 5, print, and then x. And you can see the interpreter's working. We got Python working. So we have everything we need to make this work. We just have to let Stable Diffusion, or not Stable Diffusion, the web UI update its dependencies. Very easy way. Hopefully, again, this is meant to be a pretty quick video. assuming this works, we just click, there's several different files here. We want web UI. Windows batch file. This is a Windows scripting file. So down here, these are shell scripts. These will work on Mac OS and Linux. But we're in Windows, and I don't have the stuff installed to use shell scripts. So here's what it actually looks like if you're curious about this. Also, I mentioned in the other video, this is a thing Microsoft and Apple does as well. If you pay Microsoft that you're a certified developer, it will not throw this warning. Everyone else that it's going to throw this warning on, it's just another revenue stream for Microsoft to get a bit more money. If you download it from GitHub, there's a pretty good chance it's safe. And again, you're watching this video, so I'm going to run it anyway. We're not going to destroy the computer. And plus, we're just looking at this file anyway to see what it does. So again, this is a Windows batch file. It's going to do a couple things on your Windows system. It's going to update Python. It's going to create a virtual environment with Python. And then it'll ultimately launch Stable Diffusion through Python. So that's all this file is doing. So we want the Windows batch file because we're in Windows. So I'm going to double click this. It'll create the virtual environment. It'll check dependencies. It'll have to install Torch. That'll take a few seconds, and a few seconds, I mean a couple minutes. And then once Torch is installed, it'll update a few more dependencies. And then it should just give me the localhost URL so that we can access our interface for Stable Diffusion. This is going to be the longest part of this whole process, other than just downloading the actual files from the internet. We pre-downloaded them, so not a big issue. So it's going to collect Torch. Torch is I think 2.5 gigabytes, 3 gigabytes, something like that. And the command line's pretty good about updating. Sometimes it hangs, and you just kind of mash enter, and it'll just update. It'll refresh itself. But yeah, Torch, it's she a little big, but that's okay. There's 3 different of these files. There's transformers.py that started this whole thing. There's Torch, which Meta/Facebook came up with to accelerate machine learning. Okay, 2.4 gigs. And then there's I believe he was the former lead research at Tesla for machine learning AI. He's working on his own library now called LLM.C++. And his goal is to make a very lean library to accelerate this stuff to go fast. Looks like I might have had this cached from before, so it didn't take long to download. So hopefully we'll have Stable Diffusion online in a couple minutes here. Usually you see how I had to download a few files here. Yeah, it's using cached stuff where uninstalled, reinstalled, but so far everything's working right. Hopefully, like I said, we'll maybe call it a solid 15-20 minute video. I'm just going to keep talking while these dependencies install. Show you a couple things happening behind the hood here while it installs. The big choke point, why it's taking forever, is right now it's using my computer's processor and not the graphics card. So the processor is not really that great in this computer. This computer was initially built to be an interface for a graphics processor, so has an Athlon 3000 or something in it. It's even for the time, the processor's an $80 processor. It is not very good. That said, it's enough to get us online, and then we can offload everything else to our graphics cards. I keep saying graphics cards while this thing updates, so let me let's see here. Move this over here so we can keep an eye on that. Yeah, graphics cards. So if you're watching this video, you probably might have heard the term graphics card or GPU if you have a son or daughter at home that likes to play video games. That's the original purpose of this piece of hardware, was to play video games. They have dedicated, for lack of a better word, gates on the microcontroller. So it looks like a giant card, and it has these little dedicated gates that are about 2 to 6 nanometers big. And each of these cards has anywhere from 5 to 500,000 of these cores. And those cores are meant to do something called linear algebra really fast. They draw polygons in order to render video games. Video games are made up, you look at a character, you look at an older video game, it doesn't look as high def because it has fewer polygon counts. More advanced graphics cards could render more polygons using linear algebra. So this particular piece of computer hardware is very, very good at the task that also makes artificial intelligence work, which is linear regression at the end of the day. Yeah, we feed it through a neural net, all that other stuff, but at the end of the day, we are still just drawing a line through some data. And we're going to keep it on our GPU here just to, as we run Stable Diffusion, see how it goes. You see over here, everything's playing nice this time around. So we're not going to spend 50 minutes trying to figure out which dependencies are which. I had the right versions this time, and the right versions will be, again, bottom of the YouTube video if you want to download them. I'll also try to clone them over to my own GitHub repo, so that way you could just like click 1, 2, and 3. Don't hold me to that yet. YouTube's being a little weird about links. It's like, hey, you haven't posted in like 10 years. We can't trust your links, which I kind of get. Like, like, I'm not trying to sell you all like some sort of cryptocurrency or anything or an NFT or any of that stuff. I just trying to show you how to use a pretty cool tool to, like, ultimately we're gonna put a beagle on a surfboard. Maybe in a couple days, couple weeks, just depends on how fast I can record these videos. We will make Donald Trump give Joe Biden a big old French kiss. That's one of the things we could do with Stable Diffusion is effectively create disinformation. And that's one of the reasons I got so much good feedback about this is like, here's how it's done. Now that leads to the question is like, how do we stop it? But that's a different conversation for a different day and a different skill set. I just think these to use the Marge Simpson meme, I just think it's neat. So that's why I'm doing this stuff. Is I think it's neat. We can take someone's likeness, train the model to actually have their likeness. We'll use it on myself here, maybe in a couple of tutorials from now. And I'll make myself look like Tony Stark or Harry Potter. I always, like, when I was a fat kid, I was always told, like, you look like a fat Harry Potter. I'm like, cool, I guess. It'd be cooler if I looked like Darth Vader, but, I ain't Darth Vader. Like I said, there's nothing I can really do. Just keep talking, try to make this look a little bit more interesting. It's just installing dependencies. Processor's going as hard as it can. Once it's installed, though, we're going to offload everything to the graphics card. A couple of things then about the graphics card while this thing just runs. So over here, GPU 0, it's a GeForce GTX or RTX 3080 ray tracing architecture, maybe? I don't know maybe it's just ray tracing. But 3080 Ti has 20 gigs of GPU RAM. That's going to matter when we're training the models. This is independent of my system memory over here as well. So my computer itself has 16 gigs of RAM. My graphics card has 20 gigs of RAM. So that's pretty cool. And then I have another, you can think of it like a graphics accelerator, but hold on, am I speaking here? No, it's pulled together. So the Titan 5 also has 20 gigs of RAM. Now, these two use two different architectures. This is an enterprise level card for like creating self-driving cars. That's what the Titan 5 does. It's meant to do just machine learning, linear algebra, not play video games. And I've tried. I used the Titan 5s on Overwatch, and the frame rate was miserable. So again, I don't think anybody plays Overwatch much anymore. Again, I try to stay in tune with the kids and the zeitgeist of video games, but I think on the Titan 5, and this thing was like $10,000 for its day. It was a pretty good graphics card. I was pulling maybe like 80 frames a second, and then an NVIDIA 2080 Ti, like a generation behind this, was pulling like 250. But now when it comes to linear algebra, this thing absolutely just destroyed the 30. Actually, it's as fast, if not faster, than a couple of my 4090s. All right, we got a couple things happening over here. It is throwing this transformers error. That's because we're using torch instead of xformers. Again, don't worry about that if you're doing this and it throws that error. It's not even an error, it's a warning. So let's see here. I want this machine. So everything installed, no transformers. That's the last thing we saw. That is the URL that you're going to navigate to. That was in my notes. Like, we're going to open up that, go to localhost 7860. So we'll go ahead and I'll post these notes on the video as well. So 7860, that gives you your localhost interface to use Stable Diffusion. We got it running. Like, we're good to go. Now we can draw our beagle on a surfboard. So we're going to run through a couple examples real quick. We got a few minutes. I'm trying to keep the video pretty short this time. Just identified all the errors that could happen. So we're loading the model. You can see like my computer's, it's loading into RAM and not VRAM at the moment. It'll get offloaded into VRAM, hopefully. Usually it doesn't take this long, so hopefully I didn't break anything this time. Loading weights, Stable Diffusion checkpoint. Yeah, loading weights. So, okay, I swear I was messing with this window. I mentioned the command line might hold up a second. So, runtime error, applying optimization, created, okay. I save this. There's our first error. Make sure that load. Okay, it's loaded. Let's just do a quick, like a happy dog. So 512 by 512, we won't mess with any of the parameters. We'll just make sure this thing actually works. Yep. Okay, it's running. So there's our AI image right there. Using those 3 files we downloaded from the internet. We installed Python, and we just mashed automatic in with the model file, and now we can do this. Yeah, it's not a great image, but I got a couple minutes here before I have to cut off the video. So let's try to fine tune this a little bit, talk about what a couple of these settings do now that we have the ability to create images on the fly. So I'm going to change the image dimensions. This is literally how big the image being generated is going to be. I'm going to keep it a 4/3 ratio, so 640 by 480. That's typical, like that's a megapixel, right? That's a megapixel. Pretty sure it's a megapixel. Most digital photos are shot this way, and the data that this model was trained on was like something like 5 billion images. They were either 4:3 or 16:9. So the images at that ratio tend to look a little bit better. I mentioned a beagle on a surfboard wearing sunglasses. Now, the wearing sunglasses is what we call a misplaced modifier in the English language. I don't know what this is going to do, but that's part of the fun. So while that runs, let's see here. I had this running too. You can see like a slight bump in my GPU memory there. But yeah, there's our beagle. The beagle's wearing the sunglasses, not the surfboard. So we're going to generate a couple more here just for fun. Again, this gets us the very basics of playing with these files, or playing with using text to image AI in quotes generation. That's a pretty good image, actually. Still, it looks like AI, but we're going to run with this one. So a couple other parameters we can mess with here. Because I like the way this one generated, we can lock in the way it diffuses the image. So I'm going to take the seed value right here. I'm going to add this right here. So now with that random seed, every single time, as long as these parameters are the same, it's going to generate that exact same image. AI is a deterministic system. It just uses a randomized seed to create a slightly different image. For my advanced users, you know exactly what I just said. For everyone else, if I say the equation 2 plus 2, every time it's going to equal 4 unless we're in a different base system. But that details would be included as well. That's a deterministic function. It's not probabilistic. We'll get into all this later, by the way. Right now, though, we just want to make some fun images of a beagle on a surfboard. So we're just trying to figure out how to use this thing. So width and height, pretty straightforward. I'm going to give it a high-res fix here, too. No, I'm not. Let's not do that. We're just going to don't worry about the high-res fix on this video. Sorry, I shouldn't have said that. We'll do one batch count. That's how many images you want to generate in sequence. And then how many do you want to generate in a single batch. So if you do 8 by 100, that's going to generate 800 images of a beagle on a surfboard wearing sunglasses. Let's just do one for now. Again, it's going to be the same image anyway because we locked in the seed value. So I'm going to increase let's not even increase the guidance. So I'll just click generate, and we're going to look at a couple of these different algorithms over here, these sampling methods. So it's going to be the exact same image we just got. Now, I'm going to change the sampler over to the Euler ancestral algorithm. So we have the seed value locked in. Everything's identical. All we did was change the sampler. So we're going to run it again, and it'll generate a slightly different image because of the algorithm we're using. So if we go to the folder where all this is stored, hopefully automatic. Yeah, there it is flashing up there. So here's everything we've generated so far. And we could compare, I think it was using DPM Lite. That's the DPM algorithm versus Euler ancestral. And again, I prefer Euler ancestral. It's faster and generally leads to pretty good results. But you get the idea. All right, so that's how we can get started with Stable Diffusion. A couple other things I just want to point out before we wrap it up here. The negative prompt. So like it's pretty bright out there. And bright out there in this image. So I can like change it just a little bit. I could say the negative prompts things we don't want. So we're just say overexposed photo. And we'll see what that, it should generate a very, very, very similar image. We're just adding another keyword to it for the model to draw attention to. And see how the beagle's mouth changed a little bit. Okay, sure. So my advice here, depending on your use case, play around with these algorithms. I found Euler A, it's very fast and generates good enough. DPM adaptive, if you're looking for very precise images. So I'll run DPM adaptive. It does take a little bit longer to run though. You'll see it's going to iterate through here. It's going to generate an image. Then it's going to iterate through that image. Then it's going to iterate it through again. It's going to keep iterating until it reaches a convergence. So again, it takes a little bit longer. This one is oversampled at this point, but if we tuned back some parameters, this would be a pretty good image actually. Okay, last thing I want to talk about then, we're going to switch it back to Euler Ancestral. All right. Then how do the things that, what is happening behind the hood here in basic human terms that doesn't use terms like Gaussian distribution? Okay. What this is doing is it creates a static noise pattern on the first time it generates. And it's going to iterate through that static noise until it draws what it thinks a beagle is, until it draws what it thinks sunglasses are, until it draws everything that it thinks it needs from the attention keywords. And I'm putting an emphasis on attention because attention is all you need. We'll talk about that later. That's how this works. We're instructing the diffusion model on what to draw through each iteration. So here's iteration 1. That's it. That's the image. That is a static noise. Okay? We're going to do this a few more times. So we're going to let it iterate twice. And as we iterate through, you're going to see it'll begin to, so it's beginning to create a convergence. We're nowhere close to a convergence, but now we're sampling it 4 times. We get like this nice little scary stories to tell in the dark image here. It's beginning to draw the good old beagle's flappers. So you can see the beagle's like, yeah, again, sunglasses are beginning to form. It's definitely howling right there. So iterate 7 times. Okay, we're getting a little bit more fine detail. Iterate 8 times. Okay, sunglasses are pretty huge now. Iterate 9 times. I'm gonna do this until 20. I know it's not good TV, but I just realized my stupid head is in the way. So hold on. I'm not gonna fix the video for that, but what I can do is move that over here and we can keep iterating. So again, you haven't missed much. Sorry, that's why I just looked up at the monitor. Iterate 9 times, iterate 10 times. And I'll show you again, show you all the images real quick. Around 10 iterations, it's beginning to see the pause slightly disconnected, but we're actually getting close to something that looks pretty real. Again, and I'm not really trying anything. There's the pause beginning to fix a little bit. 11 iterations. And we're getting pretty close. We're getting pretty close to the truth here, or the truth of what the model's trying to generate. So that's 13 iterations. We're getting pretty good. What's that beagle doing on that surfboard? That one, it's around 14. That's a pretty, I mean, the sunglasses give it away still and the fur on him. Otherwise, that's a pretty good image right there with 14 iterations. So we'll go 15 here. Like I said, I'm going to take it up to 20 just to show you. And then once we get beyond 20, it's begin to overfit then. And we definitely don't want to overfit because then it's going to look like a little trippy. So we'll just keep going here. Again, I'm trying to be sensitive to the time I have here. And I'll show you each image side by side from iteration 1 up to 20. So there's 19, and we've already seen 20, but we'll do it one more time. And here we go. So we just generated 20 images of the same thing, sampling it several different times. So if we look at our image folder here, we begin with, this is just, let's see here, make this larger here. There's the first iteration. And you know what? I'll just make this larger still. So 1, 2, 3, 4, 5. And you see how it begins to diffuse the beagle. So it reaches a convergence. It was right there. I think it was like around 8 or 9. See how his ear changes right there? Let me get my keyboard here. The color's changing slightly. And this is why, this is one of the telltale signs when you see hair like this change around like that. That's how you know it's AI generated. Always, that's one of the signs. There's all kinds of stuff giving this away. And we'll talk about that later. But yeah, that is the basics of getting started with Stable Diffusion using Automatic 1111. If you like this video, just give me some feedback. If there's things I could do better, give me some feedback. I'm not the guy that's like, I'm a guy, guys, smash that like and subscribe. I'm not that guy. I'm a professor, and I only say that stuff ironically to annoy my students. Now, if you do want to annoy my students, please smash that like and subscribe button so I can brag about it. But otherwise, again, I'm just here trying to provide some educational content, show you all how some of these tools work for an everyday user, because there's a lot of jargon and a lot of nomenclature around this stuff. And I'm just trying to demystify it so y'all can do some cool stuff with this. Next video I'll record is how to fine tune the models. Then, like how can I take my own likeness, add it into the Stable Diffusion 1.5 checkpoint, and then we'll generate me looking like Darth Vader, or me like riding a surfboard with a beagle wearing sunglasses. There's all kinds of stuff we can do. So again, hopefully you found this useful. If not, feel free to just, well, I mean, you can leave hateful comments and just, I have feelings, I guess. All right, I'm just rambling at this point. So yeah, there's won't be an exit outro or anything. I'm just gonna shut up and cancel the video. So have a good one.